Okay, can you hear me now? Can you hear me now? Put not muted if you can hear me now. Put not muted if you can hear me now. Yes. Nice. Very nice. Very good. Hello, party people, ladies and gentlemen, boys and girls, elders, aunties, uncles. Hello, everyone. Welcome to Maths Paper 3 live stream. We had a little bit of a 2-3 minute delay, so apologies for that. But we're here now. We are here now and we are ready to start the live stream. Paper 2 was an interesting paper. Paper 1 is an interesting paper. But what's happened now is that the topics have come up, so we now know very, very likely what's going to happen in paper 3. It was a bit of a guess for paper 1 and 2, you could say. I mean, there was still some analysis. But for paper 3, this is the paper where there's only so many topics they can ask now. So we really need you guys to lock in. Yep, be fully concentrated, fully aware, and, you know, be ready to really smash this paper because it's only going to be once. It's only going to be tomorrow. You don't want to retake no paper. You don't want to be, you know, go into that cycle. Yeah, I've been to colleges. I've seen the retake students. They never get out of that retake cycle. Okay, so you don't want to be no retake guy. You want to be first shot, first kill guy. One shot, one kill. Okay. Quick scope, no scope. Warzone. Okay. What time is it? It is 8:35. I'm going to need you guys to give me 60 more seconds so we can just finalize some things on the back end. And then we are going to start our beloved live streams. Okay. Is the foundation TikTok live started? Yeah. Is it started though? Yeah, I'll share the link. It's started. So, what is this live stream? So this is going to be the higher live stream. The foundation live stream is going to be on our TikTok. Okay. So on our TikTok, if you go to tiktok.com/@ExamQA, you don't even need to download the app. You actually don't need to download it from what I know. Even if you're on your laptop, you can just go to a new tab, click tiktok.com/@ExamQA. And what's going to happen is that will be our foundation live stream. This YouTube live stream, however, is the higher live stream. Does that make sense, guys? And in terms of what specification we're going to go over, it's going to be mainly catered towards the drum roll Edexcel specification. Okay, if you're AQA and OCR, you can listen in. Okay, but it's going to be mainly catered for Edexcel. Okay, there's some overlap. I'll try to mention as well what that overlap is in terms of the specification, but this is going to be basically an Edexcel, you could say, live stream for you guys. Okay. And the link is now being put now for the TikTok foundation live stream. Is it running? Yeah, foundation running. One. And it's running now. Okay, so if you're foundation, please don't watch this one because it's going to be not that relevant for you guys. Okay. And I think and I believe we are ready. Please, guys, like the video, subscribe. You know, the like really helps us, you know, push these videos to the algorithm. We put a lot of effort into this for you guys, so we really appreciate that. Please get us to, there's about 4 or 5K watching. Get us to 5K likes. Get us to 5K likes, and that would be really appreciated from us. And subscribe so that you can still stay tuned for the the Chem Physics paper 2. That's going to be this week, and then that's it. That's your GCSEs finished. Okay, let's start now. We will be starting now. Cool. Let's start. Just repeat, this is a higher live stream, so if you're foundation, head over to the link in the chat. 3, 2, 1. We are now going to jump right into it. So, Okay, first topic we are doing that has not come up yet in paper 1 and 2 is bounds. How do you do bounds? We're going to do the following. What even is bounds? Okay, so bounds is the following. If I have a number, okay, so let's say I've got 6.5. Yeah, let's just say 6.5. I need a calculator. Let's say this is a number that was rounded to 1 decimal place. Okay, in the chat, I know a lot of you guys already know this. Tell me what is the upper bound and what is the lower bound. Okay, but I'm going to explain it now. So 6.5 has an upper bound, thank you, and a lower bound. Is there any other calculators? And a lower bound. To work out the upper bound, what you do is that 6.5, okay, what we're going to do is I'm just going to write, even though it says 6.5, I'm just going to write 6.50 here. So you always just add a 0 after the original number. Then what we're going to do is we're going to, for the upper bound, I'm going to change that 0 into another 5. So this becomes 6.55, okay? And that's my upper bound. And what is the lower bound? Well, can you see that here I've got a 50 and here I've got a 55. How do you go from 50 to 55? You plus 5. So to go backwards to the lower bound, you now minus 5. So what's 50 take away 5? That's 45. So my lower bound is 6.45, okay? And that's how you do lower bound and upper bound. Put a 0 at the end of the original number, turn it into a 5, and then minus 5 to it. Upper bound, lower bound. Let's just do one more question like that, and then we'll look at the hard question. And good, I'm seeing everyone write it in the chat very nicely. Let's say I got another number now, 87.341. Okay, so this is a number that maybe got rounded to 3 decimal places, or someone might say 5 significant figures. Okay, doesn't matter what it is. What is the upper bound and what is the lower bound using the exact same method? Okay, using the exact same method, what is the upper bound, what is the lower bound? Okay, original number, what am I going to do? Just put a 0 at the end. Okay, and that 0 that we just wrote, we keep the rest of the number, so 87.341, but then that 0, I turn it into a 5. Okay, so the upper bound, I've got this now, 3415, and then, well, how do I go from 10 to 15? I basically added 5, so now you go backwards, you take away 5, so it becomes 87.3405, okay, and that's your lower bound. Okay, upper bound, lower bound. Now, okay, that's quite easy. I'm going to show you what an actual question would look like in an exam now. Okay, guys? So what would the actual question look like in an exam? Let's look at the following question. V equals IR, and here it says I is 7.82, correct to 2 decimal places. R is 15.256, correct to 3 decimal places. Work at the upper bound of V. So, okay, well, V is just two numbers timesing each other. If I want the upper bound of V, I just need to make sure that I and R, I've worked out the upper bound of both of them too. And then I just time them together, okay? Because you want V to be as big as possible. So they make sense, right? Just make I and R also as big as possible. So I is 7.82 to 2 decimal places. What's the upper bound of I, chat? And what's the upper bound of R, chat? Write it now and tell me what the answer is, okay, before I do it. Let's see if you guys can do it before me. So I is 7.82. The upper bound is going to become 7.825, okay? And R is 15.256. So the upper bound is going to become 15.2565. Okay, so upper bound is always easy. You just slap on a 5. Yeah, you just slap on a 5. And then what is V? You just times those two numbers together now. Okay, 7.825 times 15.2565 equals, you get your answer, but then make sure you, of course, round it to 3 decimal places. Slap that boy, slap on that 5. Okay? And I think everyone's writing the same answer in the live stream. 199.382. Lovely jubbly. That's it. Okay. I'm going to show you one more question where it gets a bit harder now. Let's look at this. Okay, so this question now is slightly harder because V equals S over T, but now it's a fraction. It says work out the upper bound of V. If I want to work out the upper bound of V, but V is a fraction, wow, you have to be very careful here. Most students are just going to do upper bound of S, upper bound of T, divide them, and then move on to the next question. But if you have a fraction, you need to remember the following. Okay, so V equals S over T. If I want the upper bound of this fraction, okay, to make a fraction as big as possible, you actually need the numerator, the top of the fraction, to be the upper bound, and the denominator to be the lower bound. Wow, who was expecting that? I don't think anyone was expecting that, was you guys? If you was already expecting that, then you should expect a grade 9 tomorrow. And just, although they didn't ask it, I'm just going to show the lower bound as well. LB, V equals S over T. So if they asked for the lower bound, you would have done the top of the fraction to be the lower bound. You would have worked out that. Then the bottom of the fraction, you would have worked out the upper bound instead. Okay, does that make sense, guys? So let's just do that. Of course, they're not asking for lower bound, so I'm just going to do this version. So what is the upper bound of S? That is 4.155. And what is the lower bound of T? That's going to be 2.51. What's it going to be, guys? 55. Yeah, does that make sense? Because look, 2.516 is the original number. If you want the lower bound of that, look, you add your 0, and then it's like you take away 5 from that 60. That becomes 55. So 2.5155, or you say 55. And then you just put that in your calculator, and Bob's your uncle. And of course, make sure you round to 3 decimal places as well. And that is more or less, bounds are done. 1.652 to 3 decimal places. Okay, next topic.
And now we move on to sectors and arcs. Now, what is a sector and what is an arc length? So, we know sectors are in a circle. Okay, so let's say we have a full circle like this. Now we know that circles, they are to make the angles to 360. Okay, so if they add up to make the angles to 360, a sector is just a portion of the circle. So let's say I have something here and a line here. These two are called radii. Now radii, okay, radii are just lengths that go from the center to the edge. Center, edge. Center, of course, edge. Now, we know that this is the angle that it makes, theta. Now let's say, okay, this curvy part here is what we call the arc length. Okay, so how do I work out the arc length? Well, we know that the whole circle, okay, the circumference of it is given as 2 pi r. So we know the circumference of a circle is given as 2 pi r. So if the arc length is a portion of the circumference, the arc length must then be given by theta, the angle, divided by 360, because in total in a circle adds up to 360, times by 2 pi r, the circumference. Because remember, it's a portion. And to find now the area of a sector, because this whole thing here is what we call a sector, again, the area of a full circle is given as pi r squared. So the area of a sector is given by the portion theta over 360 times pi r squared. Okay, so for example, let's say we have a little sector here. Okay, they ask us to find both the arc length and the area. So remember, arc length is given by theta over 360 times 2 pi r. So what do? Well, we know that theta, okay, lock in, theta is the angle, okay? So if theta is the angle, it's going to be 60 over 360 times 2 pi, and r, the radius, times 10. Again, don't go changing from last time, okay? Don't be trying to think you're too smart for the calculator. Plug it in. 60 over 360 times 2 pi times 10. Bosh. Okay? 10 over 3 pi. Okay? Is your arc length. Okay? And your area is then given by theta over 360 times pi r squared. Okay? Again, 60 over 360 times pi times 10 squared. Chuck it in here. Times pi times 10 squared. 50 pi over 3. Okay? And of course, you need to take a bit of hydration. A bit of water in a can. No problem. Okay, cool. So let's look at a hard question. Let's look at a techie question. Okay, so this one right here. Okay, this one's tech. If you get in your exam, you're gonna be like, wow, I know how to do this because Albanian Batman taught me the night before. So work out the length of the arc ABC of this. So what are we gonna do? So what we're gonna do, well, if arc, okay, arc, I taught you the equation. We're cooking here. So theta over 360 times 2 pi r, okay, 115 over 360 times 2 pi times the radius, 8.2. Bosh, in the calculator it goes. Well, we're not trying to be too smart here. We're just cooking it up with our calculator. 3 significant figures, so the first 3 relevant numbers, it will be 16.5. Okay? And now the area of the shaded segment. This is the tech that I was talking about. How are you going to work it out? Well, if we look at it, we've got the whole sector here. And then we've got a little triangle as well. So what we're going to do is we're going to find out the whole area of that sector and then work out the area of that little triangle and just minus them, because that's all we need to do. That's all the article. Look, it's 4 marks. It's bare easy. So well, let's work out the area of the sector first. Again, theta over 360 times pi r squared. Theta being 115 over 360 times pi r, well, r being 8.2 squared. Straight into my calculator it goes. And then we're just going to bosh, 67.5 to 3 significant figures. Now, let's work out the area of the triangle. The area of any triangle is what, guys? What was the area of any triangle? What was the area of any triangle that we did last time? Come on. I'm not seeing enough here. Guys, we're not failing tomorrow. Yes, half A, B, sine C. We love to see that. We absolutely love to see that. So, A and B is just going to be your radii. And your angle is just going to be 115. So, half times 8.2 times 8.2 times sine of 115. Which just gives you, in the calculator again, don't think that you're too smart for the calculator, mate. 30.5. All you're going to do is minus them. 67.5. 30.5. Final answer is 37. Bosh. All five marks done and dusted.
Wow, I don't know why, but I felt really like European for like 5 minutes. But now, I don't know, I feel like way more like, I don't know how to describe it. I feel like I just had some like Indian food just now. I don't know, it's a very strange feeling that what just happened there. But guys, bosh, that was good. I like that. And let's move on to the next topic. What is the next topic? The next topic is the following. Let's go back to the PowerPoint just so we can check. Changing subject of a formula. Okay, changing subject of a formula. What we're going to do is, we're not going to spend too long on this. This is basically like general algebra, but I got like a couple questions just prepared, just so you know the different types, okay? So what are the different types? Let's have a look now. Okay, here we go. So if I got a question like this, rearrange the formula to work out x in terms of y. What basically all that means is, work out x in terms of y means make x the subject. So right now, I've got a general equation. I need to do some steps and get it to x equals something, okay? How do you do that? We're going to, okay, first step, what's next to x? What's next to x? There's 8 and that plus 3. So I need to get rid of both of them. What should I get rid of first? I'm going to get rid of the plus 3 first. Minus 3 to both sides. To get rid of the plus 3, you just do the opposite, which is minus 3 to both sides. So you get 2y minus 3 on the left-hand side equals, and now you just have 8x on the right-hand side. And now finally, if I want to get x by itself, what do I do to both sides? What's the opposite of 8 times x? Is divide by 8. Divide both sides by 8, and what was your uncle? 2y minus 3 over 8. Okay, so this is called changing. This is called changing the subject of a formula. Okay, I'm just going to do 1 or 2 more questions just so you know the different types. Okay, so here we got another question. Work out q in terms of p. Q is over here, so this looks a bit more complicated, but let's have a go. Right, basically all we need to do is get rid of this 8, get rid of this minus, and get rid of this 4, and get it to q equals. So first step I would do is times both sides by 4. So I got 4p equals 8 minus q. Okay, why did I times both sides by 4? Because the opposite of divide by 4 in maths is times by 4. So that's gone now. Okay, and I'm just left with 8 minus q that was on the top. And now I got 2 more things I need to do. Okay, if I want q by itself, I'm going to, let's do this. Let's make our life easier. I'm actually going to plus q to both sides, okay? Because I don't like minus q. I want plus q. So plus q to both sides. So left-hand side becomes 4p plus q equals just the 8 now, because the q is gone. And now finally, what should I do to both sides? I'm going to minus 4p, and that's it. You just got the q on the left-hand side, and that's all you wanted. So q equals 8 minus 4p. Okay, guys? Nice and easy. That's basically changing the subject of a formula. I don't think we need to do any more of that, okay? There is harder ones. Okay, let's just do one more. Make r the subject. Okay, and I got this r squared, a equals pi r squared. How do I make r the subject? Okay, first step I'm going to do is pi r squared is the same thing as basically saying pi times r squared, okay? So r squared is being timesed by pi. So if I want to get rid of the pi, what should I do to both sides? I'm going to divide both sides by pi. Okay, so a divided by pi, I write like that, equals r squared, because the pi is gone now. And now how do you get rid of the squared in maths? You just divide both sides by, square root both sides. So square root a over pi, and finished. That is your final answer. Of course, I wrote equals r. It's just nicer to write r equals instead. And then root a over pi. Okay? Okay, next topic. Let's see what the next topic is. That is pretty good for tomorrow. We're going to do... Okay, couple of these we might do later, okay? So quickly we're going to go over, okay, fractional negative indices. It's kind of like a paper one sort of thing. You just plug that in the calculator. Okay, we're going to skip a couple topics and we're going to go straight to, let's go straight to cumulative frequency. Yeah, come, let's do cumulative frequency. Don't worry guys, we're going to do all the juicy topics, vector proof, geometric proof, all of that stuff. We're going to do that very soon. Just make sure you're still locked in because all these topics are very important. Why are they very important? Because they're the ones that predict to come up tomorrow. Okay, so even if you feel like you know a topic, still try your best to stay focused and lock in. Cumulative frequency, the main thing is, and here's the key thing, box plot already came up. So let's just do just a pure cumulative frequency question. So that would look like the following. Here we go. A garage keeps records of the costs of repairs to customers' cars. The table gives information about these costs for 1 month. I'll be honest, the context does not matter, okay? If you're getting really confused about context, just go straight to the numbers, okay? Frequency, cost, write down. Okay, part A, it says, write down the modal class interval. What does modal mean in maths? Modal is another fancy way of saying mode. What does mode mean? The most frequent number, the most highest frequency. What's the highest frequency in this table? Clearly it's 11. So is the answer 11, chat? Can I just write 11 and go to the next question? Could I do that? No. 11 is talking about this class. It's the 200 to 400, and that is your final answer. 200 to 400. Okay, that's your part A. Okay, part B, complete the cumulative frequency table. So I think everyone knows that by now. What does cumulative frequency mean? It means basically these numbers, you write them again, but you add as you go along. So the first number stays the same always in your cumulative frequency table. So this 7, you keep a 7, but now all you do is the next number is basically the 7 and 11 added together now, which is 18. Okay. And then what was the next one? You're just going to do 18 plus that 9. Okay, and then you just keep going on, okay? So I'm just going to do that quickly. And then 27 plus 10 is 37, 37 plus 8, 45, 45 plus 5, 50. Okay, cool. We've done the cumulative frequency table. And now part C, on the grid, draw a cumulative frequency diagram for your table. Okay. So this is very important, chat. Do not forget this. This is very important. If you want to plot a cumulative frequency graph, okay, you need to plot the end points with the cumulative frequency. Do not do midpoint and cumulative frequency. A lot of people think, oh, let me plot 107 and 218. No, it's all the endpoints. So let's just do that. So I'm going to plot 200,7. What's that? 400,18. That's there. 600,27. Sorry for the scrolling, but you have to do that with this topic. 800,37. And last two, 1,000 with the 45. And 1,200 with the 50. Okay, boom. Have I plotted it? Can I move to the next question? No. You need to now basically join this up all together. And when you have cumulative frequency diagrams, do not use a ruler. Okay, you have to do it freehand. Okay, and there should normally be some sort of like an S shape. In this one, it was a bit more like a straight line. Okay, but normally it's like an S shape. Okay, and do not use a ruler. Do not use a ruler. Okay, finish. I've done the part C. I've done the part. Oh. Okay, there should be part D now, and then part E. Okay, part D, use your graph to find the median cost. Okay, to find the median from the graph, you look at the total frequency, which was the 50. Okay, and then you divide that by 2, which is your 25. And then, okay, some people are asking, do you not connect it to the 0? Okay, so guys, in GCSE maths, it doesn't matter if you connect it to the 0 or not, okay? So if you left your graph like this, you get all the marks. If you did force it to join to the 0 as well, you still get all the marks, okay? So it doesn't really matter. You can choose one of the two, okay? Let me just carry on now to part D. So total frequency is 50. You divide that by 2 and you get 25. Chat, is that my median? Can I move on? Yeah, is that my median? Can I just move on to the next question? 25, that's it. Bob's my uncle. Good. I'm seeing some no's. You can't do that. What you do now is, basically that 25 you just worked out, that's what you search for, or let me phrase it better, that's what is on your y-axis, okay? But now you need to look for what does that 25 actually mean in terms of your x-axis. So you go to 25, you just draw like a horizontal line there, and then a vertical line down, and then you read off what that number would be, and it looks like that number, okay, in terms of the scaling, would be £560, okay? That's it, and that is the median cost. Okay, good. Okay, guys. And then part E now, use your graph to find an estimate for the number of repairs which cost more than 700. Okay, again, that might be a bit of a scary sentence for some people, but let's just think about that, okay? So they're saying estimate the number of repairs which cost more than £700. So in the part D, I went from the y-axis to the x, but now in part E, I'm going to go from the x-axis to the y. So I'm going to look for £700. £700 is of course over there, right? Then I'm going to go up. And then after I go up, I'm going to go left. Up, then left. Boom. And then left. And then what number is that there? That is a 32. Okay? So is my answer 32? It's not 32. It says find the estimate for the number of repairs which cost more than 700. Of course, more than 700 is all of that, isn't it? In other words, it's basically, that part of the graph. Okay? So if you said 32, that's talking about all of these. That's talking about less than 700. So what do? You need to work out, how many people are between 50 to 32. You just take away. So 50. Take away 32, you're left with 18, and that's it. Well done. 18. Okay, let's move on. Guys, moderators, if they're saying some mad stuff, yeah, don't even ban them for 5 minutes. Just ban them permanently. Hide user from the channel. We don't want these unserious guys. We want people that are locked in. Yeah? If we're seeing the G word, if we're seeing the B word, we need them to be gone. Be gone. Okay. Okay, next topic. What is the next topic? Wow, okay. Let's go in. Circle theorems. We've predicted this like twice already, and it hasn't come up properly. So that means it's going to come up in paper 3, definitely, most likely. Okay, so let's go for it. Let's whiz through it, and let's see what happens. The first circle theorem, okay, the boss of all the circle theorems, the one that even if you're on a grade 1, you should still know the circle theorem. A radius and a tangent meet at 90 degrees. Okay, so if you ever have a tangent and a radius, boom, that's a 90 degrees. So how would that actually look like though in the exam? Okay, it might be like undercover sort of theorem. Here we've got a diagram. Can you see, look, here's our sort of tangent, and then that's our radius. Okay, so what is this angle? That's a 90 degrees. So the question is work at X. Of course, we know that angles in a triangle add up to 180. So you just do 180, take away that 90. Oops, 180, take away that 90, and take away that 30. And you have 60 degrees, which must be the X. Okay, so that's the first circle theorem. Let's go to the next one. Okay, this is kind of like called the bow tie circle theorem. Okay, it looks kind of like a bow tie. Okay, so if you have this kind of bow tie shape, okay, in a circle, we say that the top 2 angles are the same and the bottom 2 angles are the same. Okay, And what is the name for this? Because remember, sometimes they can say, give a reason for your answer. In fact, most questions say, give a reason for your answer. So you have to memorize this sentence. And there's going to be a summary at the end. So I would say don't really maybe make notes of this just yet. Maybe just take a screenshot of the summary I have at the end, okay? Just use this for understanding. And yeah. Okay, so angles in the same segment are equal. That's what you write if you see, give a reason for your answer. And very easy example, look, you have a bow tie, that angle is 70. So what's that? That's just 70 as well, okay? Okay, next one, angle in a semicircle is always 90 degrees. What does that mean? Okay, look, if I draw a diameter, so can you see that I've split this circle into two semicircles? Semicircle there, right? Now from the semicircle, if I make a triangle, look at that, wow, bang. If I make a triangle inside one of the semicircles, we say that that angle over there has to be 90 degrees. Okay, and that's it. That's the third circle theorem. Okay. And what does it look like in an exam? There you go. It's just that, you know, that semicircle looking triangle. And it says, what is x? Is x 90 degrees, chat? Can I write 90 degrees, boys and girls? Yeah? No. Oh, I actually saw someone wrote 90. Can someone ban that boy up? He said 90. Someone ban that boy or girl. Nice, thank you very much. It's not 90 degrees. This is the one that is 90. If that is the one that is 90, what is x? 180, take away 90, take away 70. Okay? And you're left with 30 degrees. Is that 30? What even is that? Yeah, I think that is 30. No, it's not. 20 degrees. Okay, nice. Okay, next one. Let's move on. Fourth one, two tangents from the same point are equal in length. That's a bit of a mouthful. All it means is, look, if I have a point in here, okay, that's the point, and then if I make two tangents from there, boom, boom, okay, all we say is that basically that length where it up until it touches the circle, so that length there are the same. So if that was 6 centimeters, the other one is also 6 centimeters. Okay, people are saying, is this foundation or higher? This is the higher live stream. If you want to go to foundation, go to tiktok.com/@ExamQA. You don't even need the app, you can just do it from your browser. Okay, what does this actually look like in an exam though? Here you go. You have a point outside the circle, and then you have a triangle. But look, the triangle is made from two tangents. So what does that mean? Those two tangents are the same in length. If they're the same in length and you have a triangle, remember what kind of triangle is that? It's called an isosceles, isn't it? Isosceles. Isn't that what it's called? Isosceles. Or is it yeah? Huh? Someone said a funny joke in the back. But if you have an isosceles triangle, what does that mean? That 65 is also equal to that 65. Okay? So what is the top angle there, that x? You just do 180, take away 65, take away 65, and I think you get 50 degrees, okay? Because in isosceles triangles, the base angles are that equal. AJ Shabil first. Okay, next question. I think there's only a couple left now, guys. Huh? Stay locked in. Make sure you're locked in. Okay, last couple ones. Opposite angles in a cyclic quadrilateral add up to 180. So what does that mean? Okay, look. If I have a quadrilateral in a circle, but this quadrilateral has to touch all four corners, okay? This is something you have to be careful of because they might trick you. What I'm about to draw in the red, sorry if you're colorblind, what I'm about to draw in the red is not a cyclic quadrilateral. Look, 1, 2, 3, 4. Why is the red not a cyclic quadrilateral? Because that fourth one is not touching the circle. All of the corners have to touch the circle. If you have that, we say that the opposite angles add up to 180 degrees. Okay? So if that's 60 degrees, then that is 120 degrees. They're not the same, okay? They add up to 180. So remember that definition. Okay, opposite angles in a cyclic quadrilateral add up to 180. Here we go as well. They might make it look complicated, but look, this is a cyclic quadrilateral, even though it looks like some other shape, okay? What are the opposite angles? Look, clearly B and D are the opposites, and then C and A must be the other opposites. So x plus 75 must be 180, so therefore x is what? 105. Okay, chat, hope that makes sense. Next topic. Next theorem. This is called the bow tie theorem. All it is that this is not the bow tie theorem. This is kind of, you can say this is the rocket theorem, okay? So if you have a rocket looking shape, we say that the angle at the center is equal to twice the angle at the circumference, or the other way around. The angle at the circumference is half the angle at the center. Does that make sense? So look, if I got this shape, what is x? X is the one at the circumference, that's the smaller one, so x is going to be 40 degrees. Okay, because it's half of it. Okay, last couple ones. I think this is the last one, sorry. So ultimate segment theorem. Wow. Alternate segment theorem is the following. This one, everyone bugs out. Everyone like goes crazy over this one, yeah? But you don't need to bug out. All it is the following. If you have a tangent, just like the first theorem, okay? If you have a tangent, yeah, remember the first one, radius and a tangent, and then from that tangent, you have a triangle like this, okay? But the triangle, again, has to touch three parts of the circle. It can't just like, it can't be a triangle like this, basically. Okay, that's not valid, okay? It has to be like the one I'm drawing in the main diagram. Then we say that if you have this diagram, the bottom right angle is equal to the top left angle, okay? And other way around is true. The top right angle is equal to the bottom left angle, okay? So let's just make a sort of question from this. Chat, tell me now, this is alternate segment theorem, is x 70 or 75? Let's see who was listening. Is x 70 or 75? Who was listening? Who was listening? Good, I'm seeing the right answer. The top right is the bottom left. It's not the 70. Okay, and that's basically all the theorems you need to know. If you want to take a screenshot of this, you're not going to get given these in the exam. You kind of just have to know them and their definitions, okay? If you've done enough questions, you kind of can just do these off the top of your head. But if you don't know these by now, yeah, you're a bit cooked, but that's fine. I might just try one hard question on this and then we'll move on. So let's say you got this following question, yeah? Let's say you got the following question. Oh, I'm starting to feel a bit European again for some reason. Starting to feel a bit, I don't know. Got some feeling in my stomach. I don't know, something's. Pray for me, guys. If you got the following question, look, this looks like, I don't even know what this looks like. If I saw this when I was 6 years old, I think I might think, is this even maths? Find A and B. Okay, first you need to spot, is there any circle theorems that I have here? I can see two obvious circle theorems. Look, cyclic quadrilateral there. Cyclic quadrilateral there. Yep. This is some very thin highlighter, but cyclic quadrilateral there. Can you see it touches all 4 points? And then look, what's the second one? Tangent, and then a triangle there. Alternate segment theorem, okay? So let's use both of those theorems right now. Alternate segment theorem, if that is 20, then what is this one? That's also 20 degrees. Okay, that's also 20 degrees. Notice how, chat, I'm not fixated on A and B. When you see a question like this, you just work out anything. Okay, that's what you should be used to that by now. When you see a hard question, you just do anything, isn't it? You just work out and slowly you'll get there. Okay, you slowly get there, okay? To the correct answer. Calm. What we're going to do is we're going to carry on. Okay. Look at this, chat. This 20 degrees here. Wow, look at this. This is from another topic. I hope you saw this. Can you see that they do draw two parallel lines there? Okay. if I have two parallel lines, what is this called, chat? It starts with the what? It starts with a Z, is the Z rule. It doesn't start with the Z though. You actually call it alternate angles. We say that if that's 20 degrees, then this one is also 20 degrees. Okay, chat? Okay, good. Okay, what else is there? What else have I got? We're gonna say that, okay, this angle here, if I call it X, I actually know what X is because, look, this is a triangle, right? What do angles in a triangle add up to? 180 degrees, right? And I've got a 20 and a 70 there. So if I do 180, take away 20, take away 70, what am I left with? I'm left with 90 degrees, right? So that X that I've just put on myself is also 90 degrees. Now I can use the opposite angles in a cyclic quadrilateral add up to 180 again, because that means what? This A and this X, or X is now 90, add up to 180. So A equals 180, take away that 90. Okay, and I'm left with what? 90 degrees again. Okay, so A is 90 degrees, and they also wanted B, right? So what is B equal to? Again, just use the fact that angles in a triangle add up to 180 again, and what's going to happen is you got 180, take away 90, take away 20, and you're left with 70 degrees. Okay, so B is also 70 degrees. Okay, does that make sense, guys? By the way, make sure your working out is a lot neater than this. Can you see how they say given reason for your answer? So every time you work something out and you used a circle theorem, you need to write because, and then you write the circle theorem. Okay, so you say because opposite angles in a cyclic quadrilateral, yeah, add up to 180. I didn't write it because I'm a bit rushed for time, but when you're in the exam, make sure you do it a lot nicer and a lot neater. Okay, guys? Okay, cool. I hope that makes sense. Let's go to the next topic. Okay. What we're probably going to do now is probably start completing the square. We're probably going to start completing the square. I think my stomach's hurting again. I don't know what's happening. I think that grosh that I ate last night is messing up my stomach. It's messing up my stomach.
Completing the square. So with completing the square, okay, what's the main point of it? The main point of it is to finally get on and find the turning point. So completing the square is mainly used for the turning point. Okay. Now, sir, how do I complete the square? Let's find out, shall we? So, what does completing the square do? Well, let's say we have this quadratic right here. Okay. I can't factorize it. It's bare long to use that dusty quadratic formula. What am I going to do? I'm going to complete the square. So how do I complete the square? First thing you want to do is you always want to half this number right here. Okay? So half this number right here and put it in a bracket. So it's going to be x plus 2 all squared And then you always minus this number squared. Always minus this number squared. Okay? So it's going to be minus 2 squared, which is 4. And then plus 7, because we still had this extra plus 7 on the outside. Therefore, this is x plus 2 squared. And then minus 4 plus 7 is plus 3. So what is the turning point? Well, the turning point will just be, okay, the opposite of this number and whatever is this number. And this will be your x coordinate. This will be your y coordinate. So it's the opposite of plus 2, which is minus 2. And the y coordinate will be 3. Okay, so let's look at some questions on this and see where we can go with this. So let's see, bosh. Let's do this one right here. Okay, write down the coordinates of the turning point, x squared minus 4x minus 9. So again, first thing we do, chat, what do? We half it. Okay, so x minus 2 squared. Always minus the number squared. So we're always going to minus. So in this case, we're going to minus 2 squared. So it's going to be minus 4. And we had an extra minus 9. Minus 9. Minus 4 minus 9. If you can't do that in your head, use a calculator. Not judging. X minus 2 squared minus 13. And chat, the turning point will be 2 minus 13. Opposite of the bit in the bracket and whatever's on the outside. Okay? So, let's keep it stepping. Okay? Oh my goodness. What a juicy, juicy question right here. Okay? So, what do? Chat, first thing we do, we need to complete the square. How do we complete the square? We half. Bosh. We half that. X plus 2 all squared. Remember, minus this number always. It's 4. Minus this number squared. Minus 16 equals 0. Minus 4 minus 16, simply minus 20. Okay? And now we're trying to rearrange to find what x is. So how do we do that? We're going to do the opposite. We love opposites in maths. I love doing the opposite. We go on and we go forth. So x plus 2 squared equals 20. Now let me sprinkle a gem on you. Let me just salt bay that gem on you. When you square root, you are going to not only have positive square root, but also the negative square root. So it's going to be plus or minus 20, chat. Wow, that's a gem. Eat up that gem. Why? Because, for example, let's say you were to square root 4. You'd automatically think it's 2. But it's also going to be minus 2. Why? Because minus 2 all squared is 4. And then just to get x on its own, minus 2 plus or minus the square root of 20. And you can leave it like that. Okay, so 2 answers and bosh. That's your answer. Final answer. Wow, maybe Bob is actually my paternal uncle. Okay, so, and finally, okay, what we're going to do is we're going to use completing the square to find the minimum point and sketch the curve. So again, now, do you remember how we were talking about turning points? Okay, now, if we're talking about turning points, this, okay, we need to complete the square to find the turning point of that. So it's going to be x plus 2 all squared minus 4, because remember, you always want to minus this number squared, plus 9. Therefore, x plus 2 squared, okay, plus 5. This is my completing the square done. Okay, so what we want to do now is we want to find the turning point. Remember, actually, it's the opposite. So it's going to be minus 2, 5. Let me draw my axes. My y-intercept is 9. And guys, what does a quadratic look like? What does a quadratic graph look like? Is it U's or is it ends? U's or ends? Can't lie, my hairline might be looking like a quadratic as well, but we don't look at that. But it's a fat U. But we hope we don't get that a U grade in the exam. Let's not hope for that. So, 9, okay. Turning point, so the minimum point is minus 2 and 5. So my graph is going to look somewhat like this, better than me, hopefully. But make sure to label where it crosses, and make sure to label your turning points as well. Okay? And final thing that I want to go through, okay, is when we have completing the square, but with a number in front of the x squared. These ones are a bit techie. Okay? But don't worry, don't worry. Albanian Batman is here. So, let's see what we can cook up today. Let's cook this one up. Okay? So, what we're going to cook up, we're going to cook this up, and we are going to basically fry it, and we're going to make it proper grosh today. Proper grosh today. We want proper grosh. So, first thing you want to do is you want to factor the 3 out of the first 2. Factor 3 out of the first 2. And use a square bracket so that it kind of like differentiates from it. Okay? So, 3. So, you're going to get x. So, when you factor 3 out, you're going to be left with x squared plus 10x. And then there's a plus 4 on the outside. Next thing, okay, is you want to again half, because when we complete the square, we always half. So it's going to be 3 square bracket. Now we go back to our usual curly brackets. X plus 5 squared. Remember, we always minus this number. So it's always going to be minus this number squared. So it's going to be minus 5 squared. 5 squared is 25. Close that square bracket. And plus 4. Now here's the gem I'm going to drop on you again. This is what a lot of students, they don't actually clock and they miss it. You need to multiply these two. Okay? You need to multiply them. So it's going to be 3 bracket x plus 5 squared. 25 times 3, 75 plus 4, and that equals 0. You can then simplify that. So it becomes, let me just write it up here, 3x plus 5 squared. Okay? Minus 71 equals 0. And now again, we're going back to solving for x. So 3x plus 5 squared equals 71. Now don't rush. Don't square root immediately. Divide by the 3 first and then square root. Okay? We don't like rushing here. Okay? X plus 5 squared is 71 over 3. So x plus 5 equals plus or minus the square root of 71 over 3. So x equals minus 5 plus or minus the square root of 71 over 3. And there we go. Bosh! Completing the square is absolutely cooked up. Okay? So, someone asked where I got the 25 from. You always minus this number squared. Always minus this number squared. So we're going to minus 5 squared. Okay? So, what are we on to now? So, next topic. Let's move on to the next topic now. So, let's keep going. Okay? We're going to keep going with our next topic. Okay? Next topic is going to be, let's see here. What should we do today?
I think what should we do today? What should we do today? The next topic, after completing the square, is done now. Hope you liked that. Yes, that's completing the square topic. I've taught it so many times now in the previous years, but you know, it's something that's going to come up, isn't it? At the end of the day, paper 3 is there for you guys, and it's a predicted one. So we're gonna carry on after this. If all the topics we have done are confusing or anything like that, we're going to post this video after as a normal video. So you can go back and just check the timestamps and all that good stuff. Okay, guys? So don't worry if it's not making sense. It's going to be posted after. Just watch it slowly, and it should be good. You should be good to go, okay? Okay, couple more topics. We're going to do all the vectors. We're going to do all of this. We're going to do that. Don't worry. It's all coming up very soon, okay? So sequences in terms of the geometric proof and your quadratic sequences and all that stuff has not come up yet. So let's quickly zoom through that. Okay, guys? Cool. Just to make sure we're all on the same page, when you have just a normal sequence, okay, guys? When you have a normal sequence, okay? So let's say, for example, 6, 11, 16, 21, yeah? Let's say you got a sequence like that, okay? Yeah. They might say, what is the nth term of this sequence? Okay, how do you work at nth term? There's so many ways. If you already learned a way, make sure you use that way. But I'll just show you a method that you haven't learned maybe, or the one that you already know. Whatever you go up in, so of course I'm going up in plus 5s. Okay, everyone's saying in the chat already, good. That number that you're going up in or you're going down in, you write that number, you write an n next to it, so 5n, and then however you go from that number, so that 5, how do you go from 5 to the actual first number of the sequence, 6? How do you go from 5 to 6? You have to plus 1. So I'm going to write plus 1 after the n, and that is basically your nth term, okay? So that's just a way that I normally do it. 5n plus 1 is the nth term, meaning basically if you plug in like n equals 4 into here, you get the 4th term, okay, which is 21. We have to use this within the quadratic sequences, right? So I'm just going to do one quadratic sequence. Let's try this one, okay? So they might say work at the nth term of this sequence, right? But the issue with this sequence is it doesn't follow the same pattern we just looked at. Okay, so it goes up in 5 once, but then it changes to 7, and then it changes to 9, and then it changes to 11. Okay, so do you see the difference? We can't use that same method anymore. Okay, so what do we do in this situation? Once you worked out all these first differences, so this is called the first difference, then you work out the second difference between those numbers. So how do you go from 5 to 7? You do plus 2. How do you go from 7 to 9? You do plus 2. How do you go from 9 to 11? You do plus 2. Okay? Okay, once you've worked out that second difference, okay, so the rule now is we're going to do a half times basically that second difference, 2. Okay, so I'm going to do a half times 2, and that is equal to 1. Okay, so it's a step-by-step method. So this is let's say the first part of the method. So the first part of the method is work out the second difference, then times that second difference by a half. Okay, and we ended up getting 1. Okay, so what do you do after you've worked out that 1? So let's talk about the second part of the method now. So once you worked out that 1, you then do the following. So I'm going to do 1, and then I'm going to write n squared next to it. So 1n squared. What I'm going to do with 1n squared is I'm going to work out the first like 4 or 5 terms of 1n squared. Okay, so I'm going to work out the first 4 or 5 terms of 1n squared, meaning I'm going to plug n equals 1 into there, then n equals 2 into there, then n equals 3 into there, and then n equals 4. Okay, so 1 times 1 squared, okay, is just 1. Then 1 times 2 squared is just 4. Then 1 times 3 squared is just 9. And I'll just do one more. 1 times 4 squared is just 16. Okay? Okay. So I've got 1, 4, 9, and 16. So that's the first 4 terms of 1n squared. Okay? Then what you do now is, okay, you get the original sequence. So this 5, 10, 17, and 26. Okay, so let's talk about the third step now. So third step. And again, guys, if you already have another method for this, just do that method, okay? I don't want to confuse you guys the day before your exam. This is just the method if you've always been confused about this topic or you've never seen it before. Okay, so the third step is now is you rewrite the original sequence. So 5, 10, 17, 26, 37. And then you take away, sorry, so then I write the new sequence that I've got. So 1, 4, 9, 16. So then you take away these 2 sequences. Okay, so if I take away these 2 sequences, 5 take away 1 is what? 4. 10 take away 4 is what? 6. 17 take away 9 is what? 8. 26 take away 16 is what? 10. Okay, and then finally 4, 6, 8, 10, you just work out the nth term of that like I did right at the beginning. Okay, the easy, your easy nth term stuff. So So what is the nth term of 4, 6, 8, and 10? It's just 2n plus 2. Would you agree with that? Because it goes up in 2s. And then to go from 2 to 4, you just plus 2. Okay, finally, you've got your answer. Last step, you just combine this 1n squared and this 2n plus 2, and you write it as one thing. So 1n squared plus 2n plus 2, that is your quadratic sequence. Okay, or you can write n squared plus 2n plus 2. Okay, don't bug out if you already have another method. Okay, we get it, you know you have a method. This is just a method for those guys that have not done this before or were always confused with the other method. Okay, let's move on to the next topic. Is it -2? It's not -2. I think that's trying to confuse me. Okay. Okay. Is it? Okay, fine. Okay, so we're going to go to the next topics. But we're just going to have a quick break, okay? And Mohammed's going to speak to you guys. Let him know how paper 2 was as well. That's a very interesting thing. But I'll be back in a second.
Hello everyone, how are you? I hope your exam season is going well. Maths tomorrow, and then after that, you have no more maths ever. For those of you who don't plan to take A-level maths. For those of you who are taking A-level maths, guys, can't lie, you're actually going to love it. A-level maths, in my opinion, is more fun than GCSE maths. However, we will cross that bridge when we get there. Tonight, tomorrow, you guys have your maths exam. So let me quickly get some topic lists of what topics you guys want Zishan to cover when he comes back from his little break. So let's see, in the chat, type down what topics you guys want to do. So I can see quadratic inequalities, okay. Well, I can't even spell right now. Okay, I'm sure Zishan will be able to read my handwriting. Okay, all right, next one, let's have a look. Bounds, we did bounds already. Didn't we do bounds at the start of this live stream, right? Yeah, we did bounds already. Okay, bearings, I think Zishan done bearings already. Go to the paper 2 live stream. Remember, it's all timestamp, yeah? So let me see. We got, okay, vector proof. Vector proof. Arb did vector proof. Or sorry, I should say Zishan 2.0 did vector proof in second live stream. It's there. It's there. Okay, let's see. Give me some hard topics, guys. Topics that are hard. Topics that are going to make you lose your sleep tonight. Quadratic simultaneous equations. Okay, we done that. Okay, I'll just write this as well. Quadratic simultaneous equations. Okay. This pen is my handwriting is much better than this. Usually my pen's messed up. Okay, we got circle proof.
Yeah. Circle theorem proof.
Okay, circle theorem proof. Yeah. Okay, cool. That's a hard topic. Congruent shapes. Isn't that congruency? Yeah. Didn't we do that?
Yeah, I don't think so.
Okay, I'll put that here. What else? Oh, geometric sequences. Did we do that one?
No, that one's new.
Okay, cool.
That one's
Okay, definitely that one. Geometric sequence hasn't come up so far in any paper. Iteration, I think iteration, Arb did iteration in paper 2 live stream, yeah? Cool. So for now, I'll leave that there. Just want to say, well done, guys. You guys have, look, one piece of advice for me, okay? It's your last week of exam season. Some of you are taking your foot off the gas, whereas you should be putting it on the gas harder than ever before. The past 5 years, year 7, 8, 9, 10, 11, you've been going to school, your parents have been dropping you off, waking you up in the morning, making breakfast for you. If you don't care about yourself, at least do it for your parents. Work hard, trust me. After 1 week, you can't revise because the exams are finished. You know, you might want to revise, too late, mate. The exams are done, okay? So this last week is your hardest week. After that, guys, it's just going to be the best summer holiday of your life. Also, chemistry paper 2 live stream is going to be this Thursday, so I'll see you guys there. But Mr. Zishan is back, so Zishan, they give you some topics, maybe. All right, then, guys, take it.
Okay. Okay, let's carry on with the predicted topics. We've got a couple of these in our PowerPoint anyway, so we'll definitely go over that. Yes, we were doing in the middle of sequences, so we should complete off the last sequence, which is that sort of geometric sequence, okay? Cool. So geometric sequences, they're not as sort of fleshed out as linear and quadratic, meaning they won't actually make you work out what is the nth term of a geometric sequence, but you still need to know a bit about it. So for example, if I got this 5, 10, 20, 40, so this is not linear or quadratic, it's none of them. So if you try to work out the quadratic sequence of this, it's not going to work, or the linear, it's not going to work. This is because to get to the next number, you don't plus by anything, it actually times by the same thing each time. So if you times to get to the next number, and that number is always the same, so times 2, that's called a geometric sequence. So what kind of question would they ask you in regards to geometric sequences? What kind of questions could they ask? Oh, don't think I even have this one on my... let me just bring that up for you guys. Apologies, give me 1 second. My stomach's feeling a lot better now though. Wow. I think that grosht is gone out my system. That Albanian food that I had the other day, it's kind of gone now, so I'm feeling a bit more myself. I'm feeling a bit more Sileti now. Before I was feeling European, now I'm feeling back to my South Asian roots. I'm definitely not going to go back to that Albanian cafe again. Hey, who's been to a Somali cafe? I never used to think that Somalis had good food, and then I went to one shop in East London called Al Kaf. Yeah, and wow, I was blown away. They have some very good food there. So don't underrate certain people's cuisines. Okay, here we go. So this is a bit more like what they'd actually look like. Okay, this is a bit more what they'd actually look like in the exam. So look, it says here's the first 3 terms of a geometric sequence. Work out what x is. So look, what do we say about geometric sequences? You times to get to the next number, right? But of course in this question it seems a bit weird, like, okay, but what are they timesing by? So the rule is, well, just imagine if you had, you know, a sequence like this, right? What do you times to get to the next number? That 3. But let's say like you were really confused about how to get that 3. How could you get that 3 that I've written here if you just do one of the terms divided by the previous term? So that 9 divided by 3 would give you 3. And same thing, that 27 divided by 9 would also give you 3. So notice how those two numbers are the same, right? Doesn't matter which number you pick, as long as you divide it by the previous number, you should get that same multiplier, we call it. So I'm going to use this rule with this question. Okay? So look, that means x divided by 4, x divided by 4, that's the multiplier, right? That should be the same thing as 2x plus 12 divided by x, isn't it? Okay, that's also the multiplier. So I make that equation and then I just solve it. Okay, if you don't know how to solve that, this is a bit of a hard solving question, so let's just try this. So I've got a fraction on the left and on the right. So if you have 2 fractions and an equal sign, you do something called cross multiplication. Okay, all that basically means is, it's a fancy way of saying, to get rid of this divide by 4, you times both sides by 4. So the left hand side becomes the x, right, because the 4 is gone. And then you've got this fraction times 4. Okay, so 4. If you have a fraction times 4, by the way, all you just do is this. You just do times 4, or you just turn the 4 into a fraction, so 4 over 1. Okay, and if you do this, if you had you times 2 fractions together, you do top times top, bottom times bottom. So actually, that right hand side just becomes 4 times 2x plus 12. Okay, over, and then the bottom is just x times 1. Okay, and then how do you solve this? Times both sides by, still get rid of that fraction on the right, so times both sides by x. You don't like these kind of fractions, so times both sides by x. You get left hand side, you get x squared equals, and then the right hand side, that fraction is gone. You just left for the top of the fraction, 4 bracket, 2x plus 12, and then now this should just be an easy equation to solve. How do you solve this? Expand the right hand side, 8x plus 48, and then if you have a x squared and you have an equals and you have numbers like that, what should you always think about doing in maths chat? You've done 2 papers, you should know this by now. You bring everything to one side, okay? Make it equal 0. The key thing is, if you ever see x squared, make sure that it equals 0. One of the side is equal to 0. So I'm going to bring this 8x and this 48 over by doing what? Minus 8x to both sides and minus 48 to both sides, okay? So the left hand side becomes x squared minus 8x minus 48 equals 0, and then you can just plug that in your calculator, or you can factorize this. However you want to solve it is how you solve it. So what are the factors of minus 48? You've got 4 times minus 12, okay? Or yeah, I think it actually works, isn't it? Because that's a factor of minus 48, 4 times minus 12, and if you actually do 4 plus minus 12, you will get that minus 8. So that's my factorization done. So I'm going to write x plus 4 bracket x minus 12 close bracket equals 0. So what are my 2 final answers? Wow, I see some bang outs right in the chat already. Which bang out wrote it first? Mr. A.XO26, well done. I've actually seen you in the other live streams. Well done. A.XO26. Good girl. Oh boy. X equals minus 4 and x equals 12. Bob's your uncle. Bob's your uncle. Well done. Okay, that's geometric sequences finished. Let's go to the next topic. Okay, vectors. We can go over vectors. What time is it? It is 9:50. We did go through vectors in paper 2 already. So maybe it might be better to do another topic right now and then come back to vectors. Just if we still have time, because you can just technically look at the paper 2 live stream for that. So I might come back to vectors actually. That might be a better idea. Yeah. But should we do vectors now? What do you think, chat? Should we just do vectors? Okay, some people saying just do vectors. Okay, let's just do vectors. Fine. 3D, yeah. Yeah, some people are gonna bug out otherwise. Okay, and we got quite a few more stuff as well. You got parallel perpendicular lines and all that kind of stuff as well, okay? Okay, so vectors, we'll try to do it really quickly as well, because yeah, time is of the essence. We've got about half an hour left. So let's just bang this out, okay? Okay. So the key thing about vectors is all about, so if you ever see a vector question, remember, is all about alternative routes. Guys, if you're looking for the foundation live stream, head over to TikTok, okay? Foundation live stream is on our TikTok. Okay, vectors is all about alternative routes. So what do I mean by that? So let's look at this question, for example, okay? Okay, ABC is a triangle. So they've given this route here. AB is this, AB is B, this AC is C. Notice how the arrow is going in that direction and the arrow is going in that direction. So what that basically means is, although AB is little a, that means B to A, the other way around, is minus A, okay? So just be careful with stuff like that, okay? Because the direction matters in vectors, okay? So let's carry on. So the question says, M lies on the point BC such that BM is 3/4 BC. Okay, what does that mean? So this line BC, apparently there's an M here such that BM is 3/4 BC. So that is 3/4. This part is like 3/4 of the line. So of course, if that part is 3/4 of the line, it just means that part is what? 1 quarter of the line. Find AM in terms of BC. Okay, so A to M. Can you see that on my diagram, there's no like, they don't say anything, you know, in terms of, there's no particular way to get there, right? There's not like a 5D all of a sudden that I can just write, oh, A to M is 5D. Yeah? So what you have to do is you have to realize, okay, there's no direct route, so let me take an alternative route instead. Okay, so what I could do instead is I can go A to B first, okay, and then B to M next. Okay, and that means I've started from A and I've end up at M. You got AM. So let's do that. So AM is the same thing as A to B, then plus B to M. And AB is just B plus, okay, what is BM? Baby mama. So BM, again, it's a bit of a weird one, okay, because it says 3/4. Can I just write 3/4 here? No, I can't just write 3/4. BM is 3/4 of the whole line, which is BC. Okay? Now, can I just write this as my answer and go to the next question? No, I can't do that. In vectors, okay, it's all about, you have to write your final answer in all these little lowercase letters. There should never be any uppercase letters in your answers at the end. Okay, so I'm going to carry on breaking this down. So this is the same thing as B plus 3/4. Okay, BC, what is that in terms of little letters? BC, what is BC in terms of little letters? Would you guys agree with me that B to C, again, there's no direct route there, right? So that's fine. B to C is the same thing as B to A, then A to C. Okay, so BC, I'm going to write it up here, otherwise it's going to get messy. BC is just minus B plus C. Good, boys and girls, very good ones. Good, very good. And then why did I even write this BC? So I can use it here for this 3/4 BC. So 3/4 BC is 3/4 of minus B plus C. I've got everything in terms of my little letters, so that's technically my final answer. But you should kind of expand this and simplify this. So this becomes B, and then you got 3/4 times minus B. So that's minus 3/4 B, of course. And then you got 3/4 times C, so that's plus 3/4 C. And then you just simplify this, because this B is like saying 1B, right? So what's 1B? Take away 3/4 B, that's just 1/4 B. Okay, and then you got plus 3/4 C, and then finish. That's your final answer. Or if you want to factorize a quarter, then you can write this as well. Okay, next question. Next question, let's go. Let's go. I think I'm just going to do one more question. I'm not going to do any more than just one more because of timing. We're going to look at this question here. We're going to look at this question here. Okay, the diagram shows a parallelogram. The diagram shows a parallelogram. It's got all your stuff on there. OA is 2A, OB is 2B. D is on the point OC. So look at this. Look at this sentence here. D is on the point OC such that OD to DC is 2:1. Wow. OD to DC is 2:1. What does that mean, chat? In terms of fractions, right? Because it's better if you turn this into fractions when you have a vector question. That means if I want to convert 2:1 into a fraction, remember, what is 2 plus 1? 3. So that 2 actually means 2/3, and that 1 actually means 1/3. So OD is basically 2/3 of the entire line, and DC is 1/3 of the entire line. Very good, chat. I'm seeing some smart people here with their writing their fractions. Very good. And guys, this is a hard topic, okay? So if you understand this, you're doing well. You should take A-level maths. If you understand this topic, yeah, just take A-level maths, trust me. Okay. So let's carry on. I've turned it into that fraction. And they say one more thing. E is the midpoint of BC. So here we've got BC is the midpoint. So that's half and that's half, isn't it? Okay, let's move on. Show that ADE are on the same straight line. Okay, so if you ever have a vector question that talks about a straight line, okay, and you've got 3 points. So the rule is, so you work out the first two capital letters. So I'm going to work out AD, and then you work out the first and the third letter, AE. So I'm going to work out AD, and then I'm going to work out AE. Okay? You could actually work out DE as well, but I'm just going to stick to what I've written here instead. Okay? So let's do that. Oopsie daisy. Okay, so let's work out these two things, AD and AE. So I'm going to work out AE. So I'm going to work out AD first. So what is A to D? So here to here. Can I go straight from there to there? No, I can't. There's no, the question hasn't told me anything like that's 5D or, do you know what I mean? So that's fine. Take your alternative route. What's another way of going from A to D? We can do A to O first. We can do A to O first, and then O to D. No worry, no worry, no worry. So A to O plus O to D. Okay, and that's equal to A to O is minus 2A because you're going against the 2A. And then OD, very easy. OD is just 2/3 of the whole line OC, isn't it? 2/3 of OC. And who can tell me what OC is? I bet you guys can do it in your head. Who can do OC in their head? OC is just, wow, look how easy that is. OC is literally just, you can say 2A plus 2D, isn't it? Sorry, 2A plus 2B. Okay, why is it 2A plus 2B? Because in a parallelogram, opposite sides are parallel. So just like how that OB is 2B, I'm allowed to also say AC is also 2B. Okay, because it's a parallelogram. So OC is also 2A plus 2B. Hope that made sense. If not, just rewatch it at the end. And then that's it. I've got everything in terms of little letters. So that's my AD finished. And you can simplify this. But I might do that later, okay? So we worked out AD is that. I'm going to simplify a bit later. Let's just work out AE now. Okay, let's work out AE now. So AE equals, or can someone simplify that in the chat for me? Whoever's good at this topic, can someone do that for me, yeah? AE, that was the second thing I need to do. Remember chat? Remember right at the beginning, we're working out AD, and then we're working out AE. So what is AE equal to? So that's fine. A to E, yeah? I'm going to do the following. I'm going to go around like this. A to C first. AC plus CE. Okay, that's the easiest way. You could go the other way around, but that's a bit long. So AC plus CE, which is just 2B plus a half of CB. CE is a half of CB, right? That's what they said in the question. So that's 2B plus a half, and CB, again, CB is just parallel to AO. So we can use that 2A again. But of course, we're going against the 2A, right? We're going downwards. So it's actually half of minus 2A. Okay, so final answer is 2B. And also half times minus 2A is just minus 1A. Finished. Okay, I've worked out AE and I've worked out AD. This is a 5-mark question. You've pretty much got 4 marks out of 5. You've pretty much got 4 marks out of 5. How do you get the last 5th mark? That's that bit. I'll be honest, chat. If you don't understand it, just get your 4 marks and move on. Okay? Sometimes it's not even worth getting that 5th mark if you haven't done this topic before, or if you're short on time. But I'm just going to show you it now just for the sake of it. So what you do is the following. You have to compare AD and AE, see if there's a scale factor between the two vectors. Okay? So now I need to simplify this AD thing. So AD, I got minus 2A plus 2/3 of 2a plus 2b. So let's just simplify that. So I'm going to expand this 2/3 out. So I get minus 2a. What's 2/3 times 2a? If you just, oh, that's a bit ugly. But if you just use your calculator, because this is a calculator exam, you just get 4/3a. And you get plus 4/3b. And then again, just use your calculator. Do minus 2 plus 4/3 in your calculator. And what you'll get is, what do you even get? I used to be able to do that in my head. You get minus 2/3a plus, and then you got your 4/3b. Okay, so I've simplified AD, and I've simplified AE. So is there a scale factor between AD and AE? Yes, there is. Who can see what it is, chat? Who can see what that scale factor is? Look at this. If I factorize out 2/3 from AD, if I factorize out 2/3 from AD, look at this, chat. 2/3 bracket, it becomes what? Minus a, and then plus, just put 4/3 divided by 2/3 in the calculator, and you'll get plus 2b. And isn't that exactly the same as your AE? Isn't that exactly the same? I wrote the A bit first. And that's it. You're finished. You're finished. You're finished. Look at that. So can you see that AD, so look what I've just written. AD is 2/3 of, can you see that 2b minus a is the same thing as that? And that is AE, finished. As soon as you've written this sentence here, you got your 5th mark, and you move on to the next question. Bang. Toxic Karma said, why did I actually understand that? It's because you should do A-level maths, and you're going to get 5 marks tomorrow on this vector question. Let's move on. Bang. Busted. Beautiful. IQ is below room temperature. Mohammed, that's very rude. You should take that back. Okay, next topic. Wow, we're cooking today. We're cooking hard. We're cooking in the kitchen so hard that we might even end up making fish curry. Gualmas. Masbiran. Okay, next topic we're going to do is congruent triangles. Bang. Oops. Congruent triangles. So that has not come up yet. So you should expect a congruent triangle question in the exam tomorrow. So what is congruent triangles? It's probably the deadest topic in GCSE maths, but it's a topic, so you just have to know it anyway. Okay? So congruent triangles. Let's do this now. Are you ready, chat? Let's go. Okay, what does congruent triangle means? Congruent means, if you're good at English, you should know this, it means the same. Okay? So you can use this word in real life. Me and my European counterpart are congruent. We're the same. Okay? It's just a word in English. Look at this. These two triangles, we say that they are congruent if you can prove any of the following 3 things. Okay? If you can prove that they have all 3 sides the same, so 4, 4, 6, and then a 4, 4, 6. If you can prove that it's a 4, 4, 6, 4, 4, 6, then you prove that they're congruent. Or if you can prove that they have ASA, 2 angles and 1 side the same, you've proved that it's congruent. Or lastly, if you can prove that ASS, angle side side, are the same. Okay, that's a bit rude actually. That spells something a bit crazy. So let me change that. What is that? That's SAS, isn't it? Yeah. SAS, if you can prove side angle side the same instead. Whoever's laughing, moderators, you need to ban them. Whoa, how did the moderator write that, fam? What the hell? I think that moderator needs a timeout himself. Okay. Okay then. That moderator is a very interesting one. Okay. So, okay, let's do this. How can you prove that any of these three things? It's a bit arbitrary, but let's look at an actual question, okay? SSS, ASA, or SAS. If you can prove any of these three things, you prove that it's congruent. A lot of people can think about this RHS thing as well. I'll be honest, if you know about RHS, use it. If you don't worry about it. It comes under one of the three things anyway, okay? So it doesn't matter that much. So let's do an actual question on this. Let's do a question on this. Boom. Okay, I've got two triangles here. Let's prove that those two triangles are congruent. Let's prove it. Let's go. Okay, so for these questions, you have to like write some words. You have to write sentences, okay? Unfortunately. Prove that ADB is congruent to CDB. CBD. Who knows about that? CBD. I need some CBD right now. Triangles. Let's do this question. Okay. And they've given this. They've told you that AB is BC, which is CD, which is DA. They told you those four lengths are exactly the same. Okay? So we're allowed to use that in our reasoning, in our proof. Okay. Okay, first thing I'll say is that, so between the two triangles, I can say that, well, AB and BC are the same. AB is equal to BC. That's my first S. And you have to give a reason for your answer. The reason is, of course, it was given in the question. Given in question. Okay, so you're allowed to just quote that. Okay, second thing. I've got an S. That's cool. I need to look for another S or another A. Okay, second thing is that, or AD is also equal to CD. Why is that? That's another S, by the way. Again, that's just given in the question. Okay? That is your reasoning. Okay, boom. That's another S. Can I work out another S? What's the only other thing that is the same? Okay, trying to prove any angles is the same here is kind of hard because they haven't given you enough information about angles. So you might have to look for another S. What is the other S? Boom, it's that BD. Okay, so I'm going to say what? BD is shared between the two triangles. In other words, it's the same, isn't it? They both have that same length, BD, that side. Okay, SSS, Bob's your uncle. Move on to the next question. You've got your 4 marks. Okay, therefore they're congruent. Therefore, ADB and CBD oil are congruent. Okay, let's look at one more question because that was a bit of like they gave you so much stuff, isn't it? So it was a bit of like a weird question, but we're gonna look at this one now, okay? Or instead of shared, you can say common. They're both is common between the two triangles. Let's look at this question. It's a slightly different one now. There's less stuff that's just given. Prove that CDG and EFG are congruent. So those two triangles here. So this and that prove they're congruent. Okay, let's go. Let's do this. Okay, first thing, I'm just going to use this. Okay, because they told me I might as well. CD equals FE. Boom, that's a side done. What is the reason? It was already given in the question. Given in the question. So I've got one of the sides. Okay, 2. Okay, what else is now? I can't just rely on what's given. I need to actually think now. Okay, so what else can I say? I'm going to use the following. There's a lot of different stuff you can use. I'm going to use the fact that this angle is equal to that angle. Okay, how do you write that angle in maths? We're going to say CGD, angle CGD. So how do you write angle CGD? You write like this little sort of, it's like that. Okay, that's how you represent an angle. So you write that symbol, and then you write CGD is equal to FGE angle. And then what's the reason, chat? Who knows the reason? Because opposite angles are equal. Okay, so that's an A now. Hopefully there's not another S, so I don't need to write that rude word. So that's S done. Sorry, that's A. So A. So S, A. I just need to look for one more thing now. Is there anything else that's the same? Yeah, I mean, look, those two lines are parallel, so I can use my angles in parallel lines knowledge and say that. I can say that this angle is equal to this angle. Why is that the case? Because you've got this sort of Z angle. Of course, you don't actually write Z angle in the exam, but you say, so angle CDG equals angle GFE. And what is the reason? The reason is because you can say alternate angles are equal. And then that's it. Finished. S. Sorry. A. Okay, can you see that's your ASA? Finished. Therefore, the two triangles are congruent. Okay, let's move on. Bang. Okay, last few topics. Last few topics, and we're going to call it a day, and that is maths finished forever. That is maths finished forever and ever and ever. Okay, we've done quite a bit. Let's move on to let's try do some parallel and perpendicular lines, because that hasn't really come up yet. Okay, chat, let's move on. So this new topic I'm going to do is called parallel and perpendicular lines. Okay. The thing is that, so equation of a circle has already come up, but they normally ask this kind of mad question, equation of a circle. But you need to know parallel and perpendicular lines to even answer that. So let's go through that first, and if we have time, we'll go through a hard equation of a circle question. Okay. So first thing is, what is a parallel line and what is a perpendicular line? So in the topic that I'm about to teach, parallel lines means something slightly different to what we were looking at before. So before, the main thing about parallel lines is like, you know, there's two lines that never meet and they have this arrow sort of thing on both of them, right? But in these kind of coordinate questions, okay, the main thing about parallel that you need to know is that parallel means if two lines are parallel, they have the same gradient. If two lines are parallel, they have the same gradient. And if two lines are perpendicular, what that means is one line's gradient is the negative reciprocal of the other one. So we'll talk about what that means. Hopefully most of you know kind of what I'm talking about. So let's say that I've got this red line here, yeah? And let's say the gradient is 6. If I have another line like here and they're parallel, that means this green line also has a gradient of 6. And what is the gradient formula, chat? Who can tell me what the gradient formula is, chat? Gradient equals, there's so many different, you know, things you can say. I'm just going to use this general formula, y2 minus y1 over x2 minus x1. That's what I'll be using today, okay? But if you have your sort of change in y over change in x and all that stuff, use that instead. That's fine. That floats my boat, no worries. Now perpendicular lines though is the following. So say I've got this line here and the m is, I don't know, 5. And so what happens is if you have a perpendicular line, right? So this blue line we say is perpendicular. If it's perpendicular, that means the gradient of this blue line is minus 1 over 5. Okay, that's called the negative reciprocal. Okay, and basically what it means is it means at 90 degrees. I'll just show you one more example. Let's say the m was not 5. Let's say the m was a fraction. I'm going to say 2 over 3. What is the negative reciprocal of 2 over 3? What's the gradient of the other line? Basically, the negative reciprocal is you flip the fraction and you make it negative. So it's minus 3 over 2. Okay, so the blue line would be minus 3 over 2 if it was a fraction instead. So let's just keep that to the side and let's do an actual question on this now. And yeah. Okay, so it says line A passes through the points 4, 7 and 2, 1. So maybe it looks like this, right? 4, 7 and 2, 1. Okay. And then it says find the equation of the line parallel to A that passes through 5, 10. Wow. So that's basically just a completely another line. So they're saying, so imagine this is 2, 1. And that's 4, 7. What they're saying is there's a completely new line at 5, 10, but apparently it's parallel. So it's got that sort of same gradient, yeah? And they're saying work out the equation of that line. Okay, so what you do is the following. You don't need to sketch it, by the way. I just sketched it just so you have a better understanding. 5, 10. So what you're going to do is this. You're going to work out the gradient of the first line. So step 1, work out the gradient of the first line. So how do you do that? You just do change in y over change in x. y2 minus y1 over x2 minus x1. So if I do that, I'm going to do 7. I'm going to do the bigger number. 7 take away 1 divided by. Now, because I chose 7 take away 1, I have to now go back to the 4, 7 coordinate and do 4 take away 2. Okay? Make sure you're consistent. If you do 7 take away 1, you have to do 4 take away 2. You can't randomly now do 2 take away 4. Okay? So be careful of that. So that's 6 over 2, which is just 3. So this gradient is 3. So now the other line that they're talking about, find the equation of the line parallel to A that passes through 5, 10. The other line, I already know the gradient, isn't it? So the other line, so firstly, equation of the line, chat. What does the equation of the line mean, chat? It means I need to work out y equals mx plus c of this new line. But I just worked out m already by working out the gradient of the other line. So I can fill in my y equals mx plus c and straight away say y equals 3x plus c. Okay, I can use that gradient that I just worked out. And now, once you've worked out m, all you need to now work out is the c. Okay, so that's a rule in equation of line. You just work out m, you work out c. How do you work out the c? So the rule is to work out c, you plug in any line, any coordinate on the line. And what's the only coordinate we know of the new line? Is the 5, 10. So I substitute x equals 5 and y equals 10 into y equals 3x plus c. And you get 10 equals 3 times 5 plus c. So I just substituted x equals 5 and y equals 10. And now you solve this. So 10 equals 15 plus c. So chat, what is c equal to? Minus 15 to both sides. And Bob's your uncle. C equals 5. So what's the final answer? I can't just go to the next question. Yeah, you need to actually write the final answer, which is y equals, okay, plug this back into here now, y equals 3x minus 5. Wow, lovely stuff. Superb, sublime, fantastic, excellent. Isn't that amazing? Next question. Okay. I'm just going to do the same version but perpendicular instead. So line A passes through 1, 5, 5, 7. So if I just sketch that briefly, you don't have to sketch, okay? I'm just doing it just so it makes a bit more sense. So 1, 5, 5, 7. Okay? They're saying find the equation of the line perpendicular to A that passes through minus 1, 7. So they're saying that there's another coordinate of minus 1, 7. Maybe that's over here, right? Minus 1, 7. They're saying that find the equation of the line perpendicular to A that passes through this. So maybe there's another line that looks like this, isn't it? Okay, that hits us at 90 degrees, and now they want this red line. Okay, they want this red line. What is the equation of the line? This red one. So how do you do that? First step, the original line, line A, okay, you just work out the gradient of line A. Okay, so what's the gradient of line A? This black line. Again, sorry if you're colorblind, my bad. You just do change in y over change in x. So I'm going to do 7 take away 5, take away 5 take away 1. Okay, and you'll get 2 over 4, which is just 1 over 2. So I've got the gradient of the first line. So second step, chat, what's the gradient of the red line now? Chat, it's perpendicular, isn't it? So what's the gradient of the red line? What's the gradient of the red line? You can tell me. It's a fraction, so you just flip it and you make it negative. Oh my days, people got it wrong. They're saying 2x plus 5. Get in the bin. You two boys, who's that? I'm calling you out. Amal and Snowdrop, get in the bin now. Go. Flip it, make it negative. Minus 2 over 1. And minus 2 over 1 is just, of course, minus 2. Okay? So I've got the gradient of the red line now. It's minus 2. But remember, they want the equation of the line. So third step, y equals mx plus c. This is for the red line now, guys. Y equals mx plus c. I just worked at m. So you plug that in. Y equals minus 2x plus c. How do you work at this plus c? Okay, guys, how do you work at the plus c? Plug in any coordinate on that red line. We only know one coordinate, minus 1, 7. Boom, plug that in. So substitute y equals 7. And substitute x equals minus 1. And there you go. So 7 equals 2 plus c. Take away 2 to both sides. C equals 5. Do you see that, chat? And then make sure you actually plug that back in into the actual equation of the line. Y equals minus 2x plus 5. And Bob's your uncle. Okay, finished. Parallel perpendicular finished. I might just do one hard question on this, or actually I might do that at the end because there's not much time. Okay, so if we have a lot of time, then if we have more time, then I'll do a hard question on this. But otherwise, we're going to move on. Okay. Okay, what we're going to do is last couple topics, maybe literally 2-3 more topics, and we're going to call it a day. Last couple more topics, we're going to call it a day. Wow, it's 10:25. We will probably only take 10 more minutes, and then that's it. Probably 10 more minutes, and that's it. Okay? Okay. The next topic I'm going to go over is, drum roll or dab. Maybe I'm gonna do quadratic simultaneous. That hasn't come up yet. Okay, quadratic simultaneous. That hasn't come up yet. Let's do this. Okay, and I'm gonna do a very specific question. I'm gonna do boom, question number 4. Okay, so if you don't know how to do normal simultaneous equations, what I would say is you should know that by now. But if you don't, fair enough. Just watch the previous live stream. We have done that. Have we done that on paper 2? Yeah, we've done that on paper 2. So just check that. Okay. If you have, it's not even. There you go. Okay. If you have 2 equations like this, you do the following. Okay. One looks complicated, it's the one with the squares, and one looks easy, it's the one with no squares. The rule is you do the following. First step, you copy out the easy one, 3 equals x minus y, and you make x or y the subject of that. Okay? So make x or y the subject of that. How would I do that for this question? I'm just going to plus y to both sides. So I get 3 plus y equals x. And can you see x is the subject now? I'm going to write x equals 3 plus y just to make my life a bit easier. In fact, I'm going to write x equals y plus 3 to make my life even more easier. Okay, so that's the first step. Make x the subject or y the subject of the easier one. Once you've made x or y the subject of the easy equation, you write out the harder one now. So x squared plus y squared equals 17. And you basically substitute, you use the thing you just done, and you substitute that into there. Okay, so you know how I got x equals y plus 3. So now whenever you see x, right, you just write y plus 3 instead in brackets. So I'm going to write y plus 3 squared and then finish it off, copy the rest, plus y squared equals 17. So do you see that, chat? I've basically substituted y plus 3 into x squared. Now once you've done that, it's a very easy question now. You literally just expand this, simplify this, solve this. So I'm going to do that. Y plus 3 squared is this, double brackets, plus y squared equals 17. and then expand that out. So this becomes y squared plus 3y plus another 3y plus 9 plus y squared equals 17. Still carry that on. And then I'm going to solve this very quickly. Y squared plus y squared is 2y squared. 3y plus 3y is 6y plus 9 equals 17. And then remember chat, if you have a quadratic and an equation, bring everything to one side, make sure it equals 0. 2y squared plus 6y minus 17 to both sides. What'd you get? I don't even know what you get. I think you get minus 8. I think you get minus 8. Which means calculate for that. 9 minus 17 is minus 8, yeah. Equals 0. And now you just solve this. How would I solve this? Divide both sides by 2. And then that's very easy to factorize now. Okay, I'm just going to skip the steps of factorizing it and just do it straight away. Equals 0. So y equals minus 4 and y equals 1. Once you got y equals minus 4 and y equals 1, can you just move on to the next question? Nope. Final step 3. Plug y equals minus 4 into that equation where we made x the subject. So x equals y plus 3. I'm going to sub both my answers into there now. So x equals minus 4 plus 3, which is minus 1, and x equals 1 plus 3, which is 4. Okay? And that's it, finished. Okay? So, yeah, that's basically it. So x equals minus 1 and 4, and y equals minus 4 and 1. Okay, quadratic simultaneous is done. We're going to do a couple more things now, and we're going to call it a day. Let's do that. Okay, we're going to do algebraic fractions. So guys, with algebraic fractions, I'm not going to lie, this is a topic where your algebra has to be very strong. Of course, it's in the name, algebraic fractions. If your algebra is not strong, then I'm sorry, you might be cooked. But if you can understand what I'm about to do, then you might not be that cooked. So let's do the following. Okay, so this is a very likely question that's going to come up. This has not come up yet in paper 1 and paper 2. So it's very likely a question like this is going to come up in your exam. It might not be exactly like this, but if you just follow the working out I'm about to do, you can basically still use that in your exam. Okay, guys? Let's do this. So, oh, it's not even editable. Give me 1 second. So we're going to do this question chattily. Bang. Solve, and then you got some disgusting equation. Let's do it. Bismillah. If you see a question like this, don't bug out. Look, you just have a fraction, take away a fraction. You just do that. You just take away fractions the same way how you take away any fraction. Make the bottoms the same. So 7 over x plus 1 minus 4 over 3x minus 2 equals 1. I'm going to neglect that equals 1 for a bit. Just focus on the left-hand side for now. So let's focus on this left-hand side by taking away the two fractions. We can't take away the two fractions right now because the bottoms aren't the same. So I'm going to make the bottoms the same by timesing the top and bottom of this fraction by what, chat? By the bottom of this fraction. So, okay, so that's like a normal rule, isn't it? So I'm going to times the top bottom by 3x minus 2. Okay, and that makes sense, isn't it? Look, if you got 4 over 5, take away 6 over 11. How do you do that, chat? You times the top and bottom by 11, and you times the top and bottom by 5, isn't it? I'm doing the same thing. Don't get scared just because there's letters, yeah? I'm literally doing the same thing, but it's algebra instead, okay? And of course, I'm going to times the top and bottom of this one by x plus 1. But remember these brackets, okay? If you don't remember the brackets, you're going to have a bad day in the exam because you're going to do all that working out and you're going to have so much stuff that's gone wrong. So the first fraction, if I times the top and bottom by 3x minus 2, the top becomes 7 bracket 3x minus 2 over x plus 1 bracket 3x minus 2. Okay, minus, and the second fraction becomes this over, and then the bottoms are the same now, isn't it? So because the bottoms are the same, right equals 1 as well. So because the bottoms are the same, I can now take away these two fractions. Okay, how do you take away these two fractions? You make it into one big fraction. You make it into one big fraction, and you take away the tops. So 7 bracket 3x minus 2 minus 4 bracket x plus 1. Okay, and if you've already expanded it out, that's fine. I just haven't expanded it out yet, but that's fine. So look, it turns into this, and now I'm just going to do that. So the top now, so the top becomes what? Becomes 20, if I expand that out, okay, and I expand this out as well. So the top becomes 21x minus 14. Okay. And I'm going to do something, chat. Tell me if you find the mistake. So this is all over x plus 1 bracket 3x minus 2. I'm going to do something, chat, which everyone gets wrong. Please tell me if you can see the mistake. I'm going to write, so I'm going to expand this, right? So this becomes minus 4x plus 4. Chat, who saw the mistake that I just done there? Guys, who can see the mistake? Please let me know. It looks fine, right? Isn't 4 times x 4x? And isn't 4 times 1 4? Wow, you guys are something else. If I asked that to the live stream last year, I don't think this many people would have got it. Everyone always forgets that this plus 1, okay, fair enough if it's a plus 1. But when you expand this second bit, you're actually doing minus 4 times x, which is minus 4x. And then you're doing minus 4 times that 1 again, which is the minus 4. Everyone always forgets that, okay? And then now, okay, write the equals 1. And then that's it. I'll be honest, the main hard part is done now. You can just go ahead and relax and just do algebra like you're just on holiday, like you're just doing algebra for fun now. Okay, so this becomes what now? You can close your, I think you guys can close your eyes and do this now, isn't it? So this becomes, top becomes 17x, because 21 minus 4 is 17. And then you got minus 18 over this equals 1. And now you can start actually doing your algebra. How do you solve this? Get rid of this divide by x plus 1, 3x minus 2 by bringing it up, times both sides by x plus 1, 3x minus 2. Guys, after this, I think literally just 2 more topics and it's done, okay? So just please try to focus on these last couple topics and then that's it, done. Live stream finished. So if I times the left-hand side by the bottom, of course the bottom goes away. I'm just left with 17x minus 18 equals, and then I've got 1 times this. Of course, 1 times anything, you just keep the other thing the same. Okay, and then now it's an easy question. Expand this out. So keep the left hand side the same now. Equals 3x squared minus 2x plus 3x minus 2. Sorry, I'm going very quick. Who can keep up with me? This becomes 3x squared plus x minus 2. Now what you're going to do, bring everything to one side, isn't it? Bring everything to one side. So I'm going to bring all of this to the other side, right? So I'm going to minus 17x and plus 18 to both sides. So the left hand side becomes 0, and I'm left with 3x squared minus 16x and plus 16. Okay, that is a very ugly thing, and that's definitely not that easy to factorize, but hopefully that does have some answers. Unless I made a little mistake, I'm just going to double check that I make any mistake. I don't think I did. I don't believe I did, so I'm going to carry on. If you can't be bothered to factorize that, what you're going to do is you're going to just use quadratic formula. Good, I wrote some guys see that in the chat. Just use quadratic formula if you can't be bothered to factorize that, because even myself, I can't be bothered to factorize that. So x equals, and then of course, luckily you've got this in the exam, 2a, so you plug that in. So if I plug that in, it becomes minus 16 plus minus square root minus 16 squared minus 4 times 3 times 16 all over 2 times 3. I really hope that I didn't make a mistake, because if I did, that means you're going to get decimals, but let's pray that we didn't. That's 4 times 3 times 16 over 6. Boom, yes, you actually got a nice number. X equals 4 if you do the plus version, and x equals 4 over 3 if you do the minus version. Okay, what do I mean plus and minus version? So chat, can you see that this number here, I wrote minus, right? That's basically the minus part of the quadratic formula. Okay, but then once you do that, you click right. Okay, wow, it's stiff, this calculator is very stiff. You basically go back, and you find the minus, you click delete, and you change it into a plus, and then you click equals again, and gives you your other answer. Okay, finished. Bob's your uncle. Bye. Next topic. Okay, and it's literally hit the 2 hour mark, so I think literally just 2 topics, and then that's it, finish. Or maybe even 1 topic. Actually, I think I've done all my topics. Okay, great. Yeah, last 2 topics, graph transformations and maybe a bit of bearings as well. Graph transformations and bearings, and then that's it, finished. 2 topics, graph transformations and bearings, finish, go to bed, sleep, have a nice dream. Don't dream about me. And we're going to cook up tomorrow and get a grade 9. Okay. Graph transformations is a bit peak because it's such a hard topic, but there's literally only like a 1 or 2 mark question on this normally. But basically all it is the following. So let's say that you've got this graph here, and it says to you this thing here. Can you transform this graph by f of x plus 3? So we say that if you have f of x, which is just this graph, and you plus 3 to it, okay? We say that plus 3 means you move the graph up by 3, okay? And of course, minus 3 would mean you move the graph down by 3. So let's say now, so the blue graph is f of x plus 3, the red graph is f of x. So let's say now, yeah, your original graph had a coordinate 2, 5. They say, what happens to that coordinate under the transformation f of x plus 3? So do you see how the whole graph went up by 3, right? That means what gets affected? Only the y values get affected. They go up by 3. So what happens is, the 2 stays the same, but you plus 3 to that 5. What's 3 plus 5? It's 8. Bang. The new coordinate is 2, 8. Okay, next one. Let's say the graph looks like that again, but now they say, can you transform the graph by f of x plus 5 inside the bracket? So can you see this is different? Before it was like this, f of x plus 5 like that, but now it's f of x plus 5 like that inside the bracket. So when it's inside x, okay, we say that when it's with x, you do it in the x direction. Does that make sense? When it's outside, when it's not with x, you do it in the y direction. Okay? And it's always opposite to what you think. So you think plus 5. Oh, so that means 5 to the right. It actually means 5 to the left. To the left, astaghfirullah. So look what happens. Oh, it's not working. Yes, there we go. So let's say that same coordinate, 2, 5. What happens if you move it to the left by 5? The y stays the same this time, but the 2 is actually the thing that gets taken away by 5, and it becomes minus 3, 5. Bam. Okay, next one. Okay, look. So now we've done the plus and minus stuff. Let's say you got a times now. So instead of so say you got f of x, but they say, can you sketch 2f of x on top of this? So what 2f of x does, chat, is you times it. Remember, it's not with x, right? If it's not with x, you're doing the y. You times everything in the y direction by y, and it stretches like that. Yeah, it stretches like that. So what that means is, if you have a coordinate 2, 5 there, what happens if you stretch it by 5? You times the 5 by 2, and that becomes 10. Okay? Next one. Oh, look at that. What happens to that 3, 0? Well, look, you just times the y by 2. But of course, y is 0 in this case, so it actually just stays the same, 3, 0. Okay, last couple transformations. F of 2x, the 2 is with x now, so it's in the x direction. But whenever it's with x, it's opposite to what you think. So you'd normally think it stretches by 2 in the x, but actually it shrinks by 2, or you times it by a half, basically. So look what happens. This is f of x. What does f of 2x look like? Bang. It looks like that. It's squished up. Okay, someone sat on it, someone heavy. And what happens is 2, 5 becomes, you can guess that, isn't it? 2, 5 becomes 1, 5. Last two transformations, minus f of x. Okay, so if I got f of x like this, what does minus f of x do? It basically reflects it in the y direction, but y direction means the x-axis. Okay, so you reflect it in the x-axis, and boom, can you see that basically the y is actually what gets reflected, right? In terms of, look at this. If you have 2, 5, what's the coordinate that changes? Is it the 2 or the 5? It's the 5, and you times it by minus 1. Bang. It's a bit like logical, isn't it? Sometimes, even if you forget the topic, just use your brain sort of thing. 2, minus 5. And then the last one, if this is f of x, what does f of minus x looks like? F of minus x is a reflection in the y-axis, and the x coordinates get times by minus 1. So 2, minus 5 would become minus 2, 5. And that's it. Just take a screenshot of that, and that's the summary of this topic. And now we're going to the last topic, which is bearings. And we might do grade 9 probability because some people are requesting it, but I don't think, and then we're going to end it there. Only if people request probability, then we'll do it. Otherwise, I'm gonna finish with bearings because it's very late. I don't want to get in trouble with your parents. Okay? Okay, good stuff. We've actually done a lot of content. Oh, shout out to the parents that are watching this. I don't know if you're watching it with your children. If you are, then fair enough. But if you're watching it by yourself, then shout out to you guys. You guys can become parents very soon, by the way. You just hit 18. Don't do none of this girlfriend, boyfriend stuff. If you feel like someone that you like, get married to them. You can be a father within a couple, or a mother very soon. But do it nicely. Do it, get married. Don't do none of this boyfriend, girlfriend stuff. Okay. I think, okay, fine, yes. Let's do this. Okay, so for bearings, before we do an actual question, I'm just going to show you a principle that you have to remember. So the principle you have to remember is, if I got an A here, so if I got this here, A, and I got a B here, yeah? So there's two things they can ask you, okay? So there's two things they can ask you. So they can ask you, question number 1, what is the, work out the bearing of A from B, okay? Or the second thing they can ask you, work out the bearing of B from A. So this is very subtle, but they mean two different things. Of A from B is different to of B from A, okay? So I'm going to do the first one. I'm going to do this one first. So if you see this, what you do is, both questions, you just connect them together with the ruler. And then what you do is the following. Where it's from, you draw a vertical line going upwards, a north line, okay? Then from that north line, you go clockwise until you hit that line that is connected to A. Bang, you get your protractor and you just measure that angle. Finished, okay? But now if I do the same method, but I do it for the second question now, which I'll do in blue, what is the first step? So first step is, of course, you just connect them with a ruler. Where it's from, you draw a north line, okay? And then from that north line, you go clockwise until you hit the line that connects the two letters. Bang, and then that is your angle for question 2. Can you see they're very two different angles? One's very small, one's very big. The small one, of course, remember, if it's like 56 degrees, if it's a bearing question, make sure you write 056, because bearings, you need 3 digits, otherwise you might lose the mark. Okay, so that's the basics of bearings. I'm just going to do one bearing question and then finish. We're going to call it a day. Oh, are they saying yeah? Okay, fine. We're just going to do one bearing question and we'll call it a day. Or should I just skip the bearing question and just start probability equations? There's so many different types. Oh my days. Okay, we'll just do this one and then that's it. So look at this. Look at this. I've got a question like this. Part A, work out the actual, so it says the scale. It says part A, work out the actual distance of D from C. So that's got nothing to do with bearings. You just get your ruler. Okay, draw a line between C and D. Say that's like 5 centimeters, right? You just use this now. So 5 centimeters means 500 kilometers. Okay, so that's part A done. Okay, part B, find the 3-figure bearing for of D from C. Okay, of D from C, so you connect the two lines. It's from C, right? So from this north line, go clockwise, bang, just work at the angle. I'm going to pretend it says 60 degrees, yeah? So you're going to write 060. Okay, part C, E is southeast of C. E is southeast of C. Write down the bearing of E from C. Wow, what a question. So E is southeast from C, basically means that. So from here, southwest means, look, I've never even seen a question like that. North, east, southwest. Southeast basically means like that way, isn't it? It's literally like perfectly like that sort of direction there. All of these are 90 degrees. So of course, if I've got southeast, then that's 45 and that's 45. I need to draw like that kind of line down there. So I'm going to draw this line here. Okay. And if that was the east line, then that is 45 degrees. Does that make sense? Okay. If that was my east line, that's 45 degrees. So what does the question want? Write down the bearing of E from C. So E is here. So this E is there. Of E from C means I need to work out from C, north line, clockwise, bang, I need to work out this pink angle. What is that pink angle? Luckily, it's very easy. It's literally just, look, can you see that east line is just 90 degrees plus that 45 degrees. 90 plus 45 is 135. Okay, so 135. Shall I even do this part D? Is enough time? Okay, E is also on a bearing of 190 from D. Mark the position of C on the diagram. Okay, I think they meant of E. Okay, so E is also, so we know that, can you see this? We know that E is in this direction. We don't know how far away it is. It could be there, but it could be shorter. It could be even longer. I just generally wrote E in that direction, okay? But they gave this extra bit of info. E is also on a bearing of 190 from D. So from D, okay, I'm going to get my protractor and measure 190 degrees, okay? So you do that, you go 190 from D, that's going to basically look around like here. And then you get your ruler, you draw a straight line going downwards and bang. I actually predicted it pretty accurately. Where the red line and the purple line meet is basically your E. Finished. That's one type of bearing question that could very likely to come up. Okay. Okay, I think we're finished. I could do one more topic, but I don't know if we should. Should we do it? Mohammed, is it too late or is it calm? Time to sleep, yeah? Okay, we'll do the last, we'll just do one question and then that's it, finished. There's no more requested topics, it's just done. So, probability equation is the last predicted topic that I wanted to do. It's gone a bit over time, but we'll just do that and we'll have to call it a day. If you guys wanted 3D trig, I think we might have done that in paper 1, predicted topics, so check that out. Did we do that in paper 2, 3D trig? No. So check paper 1, there might have been 3D trig in that. So in paper 1, there actually was a slightly similar probability equation question, but it wasn't like a grade 9 one. So let's just look at one grade 9 sort of question, and then we'll pack it in. I think the best one to try maybe is... maybe this one. Let's look at this one. Let's try question 7. And that's it, guys. Paper 3 is done after this. There's n counters in a bag. 5 of the counters are white. Sally, what an interesting name, is to pick 2 counters from the bag without replacing. Given that the probability of both of them being white is 2 over 3, find n. Okay, whenever you see a question like this, when there's lots of probability stuff going on, you're just going to sort of visualize the question, get into the question, pretend that you're Sally. Okay, I'm Sally. What is Sally doing? There's a bag. There's n counters in there, okay, meaning we don't know how many there are, but we know that 5 of them are white. There's 5 white ones. So the rest are, of course, we don't know what they are. Maybe let's call it n minus 5. There's 5 whites, so how much remaining is there? N minus 5. Could be some other color. Sally is to pick 2 counters from the bag without replacing. So she picks one, she puts her greasy fingers in there. She picks one, keeps it outside. And then she picks another one, keeps it outside. Given that the probability of both of them is white is 2 over 3, find n. So when Sally put her greasy fingers in the bag and she picked a white, what was the probability of the first counter being white? Okay. The probability is, of course, 5 out of n, right? Because there's only 5 whites and there's a total of n. So that was my first pick. And in probability, as you go along, you normally times by the next probability, right? So I'm going to write times. If I picked that white counter and I left it out my bag, how many white counters would be left? 5 take away 1, 4. Out of, now, is it out of n, chat? When I do that second pick, is there still n counters left? Good. It's not n counters left because that white one was picked and you left it outside. So there's actually n minus 1 counters left. Okay. And that's it. So that's white times white. And apparently they're saying that's equal to 2 over 3. And that's it. Basically, you've got your algebraic fraction set up and you just solve it exactly like how I solved the previous algebraic fractions question. So let's, actually not exactly, sorry, this is actually easier because this is a times, there's no plus or minus. So top times top 20 over bottom times bottom, n bracket n minus 1 equals 2 over 3. Let's just solve that. So 20 over, okay, how would you solve this? Cross multiply, times both sides by that, then times both sides by 3. So I'm going to times both sides by n bracket n minus 1. Okay, so the left hand side becomes, that goes away, 20 equals 2 over 3 times n bracket n minus 1. And then what I'm going to actually do is I'm going to get rid of this over 3 to make my life easier. Times both sides by 3. Left hand side becomes 60 equals, 3 is gone. I'm just left with the 2 n bracket n minus 1. And then it's up to you how you solve that. I would probably divide both sides by 2 to get 30 equals n bracket n minus 1. Expand the right hand side, 30 equals n squared minus n. Take away 30 to both sides. So you get 0 equals n squared minus n minus 30. And factorize that or use quadratic formula. And you should get bracket n. What is that? I think that's 6 and 5, isn't it? Or min n. Which one's the plus? The plus is the 5. and the 6 is the minus, equals 0. And so you get n equals minus 5 and n equals 6. But which one do you pick? Chat, does it make sense to have minus 5 counters in a bag? No, it doesn't. So you cross that one out. You choose n equals 6. Bob's your uncle. That's your 6 marks. Bang, finished. Call it a day. Paper 3 finished. Guys, there's only 2 papers left. Admins, and guys, if you can just post the live stream 29 in the chat. If you could just post the live stream 29 in the post the plug in the chat. There's only 2 papers left, so you might be thinking, what is the point of doing that? The point is the following. Look, there's only 1 week left. We have world-class resources for science. You might think, is there any point if I got 2 exams left? I would tell you right now, look, £19, I know you guys spent that on chicken and chips yesterday. I know you spent that on chicken and chips yesterday. Invest in yourself, invest in the future, put that into your science grades by using code livestream29 and you get your £20 off. You can still use the resources that we have for science. Even for maths, you can revise a bit. I don't know if it's wise to do that in terms of it's a morning exam, so you don't want to revise too much. You want to get some sleep, of course, but use the code while it lasts. Subscribe, please like this video. We put a lot of effort into these live streams and you will do very well, okay? Look, you know how Mohammed teaches these guys when he goes to their school. They don't know anything and he teaches them for a couple seconds, bang, they know the whole of like this topic that they didn't know before. So imagine you had these slides for these next couple days when you still have entire paper 2 left. Yeah, we taught you all of these all this content in one night. Imagine you had this for still a few more days. I mean, if I was in your position, it's a no-brainer. I'm not going to rely on the live streams. I'm going to revise myself. I'm going to use these slides and I'm going to bang it out. Okay? There's more than just slides as well. There's notes, there's worksheets, there's quizzes, so use that as well. So look at this. We have a quick demo of one of these slides that we have built. Let me make it bigger, yeah? Look at this. This is some amazing stuff here. Look, this is like, I don't even know if we should, I think we should charge more than £19 personally, but look, this is a very recently developed one that was exclusive one for your chem exam.
Sneak peek at paper 2 coming up.
I mean, look at that. If you're not going to understand purity and formulations after that, then I don't even know. Wow, that was a cheeky one there. If you don't understand chem after that, then I mean, you should reconsider of doing GCSEs. The slides are there. If the website does crash, which it normally does when so many people go on it, just use the code when it stops crashing. The website is going to be still. We're going to be fixing it basically if it is crashing. So use that now. But other than that, that's me signing out. Good night, goodbye. Any last minute topics, any last minute tips I might give is, I mean, it's your paper 3. You've already done 2 papers, so you already know the drill. But don't give up. I mean, look, even if you've done bad in your paper 1 and 2, what I'd say is the paper 3 is the one that matters. This is the deciding one. Okay? Look, if you see some disgusting question on circle theorems and your whole mind goes blank, the main thing is you still want to write stuff for that question and go on to the next question. You don't want to leave it blank, okay? A lot of people, they have this mindset where, like, I'm so cooked, I did bad in my previous exams, there's no point of this exam, let me just skip this question and just go to one that I can answer, right? Look, you never know what these little method marks can do. If I could tell you something, it's that method marks change lives. You know, you deserve the grade 4. You deserved for your mom to give you beats, but you did method marks and somehow, some way, you scraped to grade 7. And instead of your mom giving you beats, she gives you £100 for each grade 7 that you got. Imagine that. That can happen, but you just have to believe. You have to be confident, and the rest is history. The rest is history. One other thing is, look, a lot of people saying, I've lost time in my exam. I was doing well, but I ran out of time at the end. Look, what did I tell you in paper 1? Get a clock right now. Get that clock in your room. And I want you to spend the next 3 minutes just getting to know the clock. feeling the clock, understanding how time works, because that's what you need to be like in the exam. You need to have a mental ticker in your brain, 1 minute per mark. That's kind of how it goes, isn't it? Look, I'm spending 5 minutes. I'm spending 5 minutes on this question. I haven't even got 1 mark from it. That mental ticker should be telling you, just skip to the next question. You need to have that mental ticker in your head. The only way you're going to do that is you have a romantic date with the clock in your room, okay? Do that now whilst there's still time, and you're going to smash that exam tomorrow. What do you say? And record it, put it on TikTok for us. We're going to repost that for you, and we're going to get you guys 100k views from our repost. Yeah? Do that for us, and that's it. You're going to have an amazing grade. Okay, that's it, done. Any last minute message from you guys? That's it? No, that's it. Oh yes, chemistry is on Thursday night. Whoa, are you sure? When's physics then?
Monday.
Oh, they've still got 2 weeks of exams.
Sunday
That is mad. Message us on Snapchat, ExamQA, add that up, and we have some. We're not going to groom you. That's not our intention. We're just going to set up some TikToks with you guys, with our team, and do that. Snapchat, ExamQA. Schedule is Chem Paper 2 live stream Thursday night for your Friday exam, and Physics Paper 2 live stream on Sunday night for your Monday exam. Good night and goodbye. Use the code while stocks last.